Hello, this is Dan Donahue's progress report for the MEMS 5001 optimization project. My chosen project was to optimize the shape of an aircraft using CAD and CFD software. I was looking to optimize some of the performance parameters of the aircraft through a particle swarm optimization scheme. Specifically, I was looking to optimize the lift-to-drag ratio by extracting those coefficients through CFD cases. To do this, I had to create an initial three-dimensional model of a baseline configuration. This was done through the use of the SOLIDWORKS CAD software available on the WashU computers. I then used the design table feature to turn the baseline configuration into a rubber model by allowing for several of the design parameters to be changed through this design table. After setting minimum and maximum bounds on each of the design variables, I was able to create an initial generation using the random number function in Excel. These 10 initial models were then the population size of my initial generation. CFD was then used to determine the maximum lift-to-drag ratio for each of these models in the generation. Then subsequent generations would be adjusted towards the best model of the previous generation, thus advancing the population towards an optimum solution. As the generations evolved, the average lift-to-drag maximum increased as expected. The maximum lift-to-drag ratio was held for the first 3 generations, which was a product of the initial generation containing a random model near the optimized lift-to-drag ratio. The stopping criteria I used for generational evolution is shown and is a function of the average lift-to-drag ratio and maximum lift-to-drag ratio coming closer together as generations progress. This essentially shows convergence towards the optimum value. Even though the maximum lift-to-drag started to increase towards the end, I have chosen to stop at this point because my stopping criteria was met and because it takes a lot of time to run the CFD cases. With this, I have stopped collecting data and will begin writing my final presentation and report. Thank you.